Hi, so this talk is about securing Java services in the cloud. I'm a security engineer at Qudini. And yeah, this is just covering some basic pitfalls, only a very small amount of them, and how you can avoid it and not be Equifax. So as Fraser pointed out, we are a customer service management solution in physical stores. Our code base is mostly Java 8 onwards, so it's quite modern code. We solve some pretty tricky scaling problems. We have lots of clients all over the world, so as we've grown, we've had challenges that we've had to overcome. And we have many large clients, including like Airtel, RBS, and well, I could list clients all day, but the point is we have many. And our main GitHub site is here, and our marketing site is there. So that's Qudini GitHub, QudiniGitHub.com, and that's Qudini, not Quidini. So I'm Louis Jackman, I'm the security engineer here, and that's my GitHub on my personal site. That's my plug. I've got many more of those, don't worry. And I was going to make a promise to you all that I wouldn't have loads of padlocks and shields and green ticks like every security presentation, but our wonderful designer at the back there, she made our slides very pretty, far better than what I gave. Mine was basically Comic Sans MS, white font on a yellow background. So she may have snuck a few padlocks in there, so I apologize in advance. The startup mentality, if you want to follow the stereotypes, is time to market is everything, and then you just delegate all of the problems until later and clean everything up. Alternatively, you just delay the cleanup until you do a company exit. Problem solved. And of course, Qudini has told me that I have to put this third bullet point in, where I really emphasize that we aren't doing that. We're doing it properly. We're cleaning up as we go. That includes security, code quality, everything else. And ultimately, when you're in a startup, breaking velocity isn't good. So lots of the security things you want to do can be adding annoying things that you have to just get done. It's kind of like yak shaving, and you don't really want to do it. But ultimately, architecting security from the beginning is actually quicker than trying to retrofit security, which just ends up being kind of a disaster if you leave it too long. So our story is that we've been around for about half a decade. We're a startup or a small business. We just pick whichever one looks better, depending on who we're talking to. And we have no dedicated security team, apart from me. I'd like to think that's enough, but who knows? And like any large company, we have limited resources. We have increasing compliance requirements like ISO 27001, and we have banks that want security assurances. So if you're dealing with a Ma and Pa restaurant, like we had at the beginning of our company, you don't really have to go into many details about what your disaster recovery policy is, but when you have RBS knocking on your door, suddenly they start caring about all of these details, and you have to give them compelling answers. Here's the thing. If I go over to a manager in our company and I say, our React forms is vulnerable, it's an old version, we've got to patch it, all they hear is techno-babble. They like, oh, okay, guess that's a techie thing. Cool, I guess you fix it then. Whereas if you actually stick a price tag on things, suddenly things start to make more sense. So if you say, oh, by the way, Equifax also had a vulnerable dependency, and by screwing that up, it cost them £500,000, suddenly you may raise the eyebrows of a few managers. Now they care. So sticking a price tag on security is important, and getting it out of the land of techno-babble is pretty critical. But here's the tricky part. You have to sell security to developers as well. And this is a really tricky one, because I'm sure many of you have been at companies where you've had pen testers coming in, and you have to do kind of annual audits from various companies. And the problem is, some pen testers are great. I want to be clear. Some pen testers are awesome. They understand constraints. They understand real-world issues. But some pen testers aren't very sympathetic to the economic constraints of real-world software engineering. They often don't understand that security holes aren't there because, oh my God, developers are idiots, they don't know what they're doing. Actually, developers do know what we're doing. I say we and I say them when it's convenient, by the way. I can kind of do both as a security engineer, which is very useful. But developers make these decisions because they have time constraints, they have economic constraints, they have reasons why they make decisions they make. So here are a few things which you kind of can read on the internet. If you go onto like Reddit NetSec or one of these things, great subreddit, but you sometimes hear things like this. You say, oh, this company got hacked, and it was just because they didn't increase one number on a dependency in a packaged JSON file. When, of course, we all know that the reason we can't do that is because we have a 5-year-old code base that the developer left, and no one who really has ownership of it anymore. And the only way we can update it is by doing a semantic version breaking changes, which then cascade with a whole bunch of other things that can potentially break client functionality. So there is a reason why developers don't just bump up the version number. Or they say like, oh, why didn't they just take the extra time to do it properly? Not taking into account that developers often have time constraints. They have managerial pressures coming down onto them. So actually, developers don't go out of their way to screw these things up. They screw these things up because they have to make a set of trade-offs with the amount of time they have. Just turn on content security policy. You're just adding one HTTP header. It's really easy. And you think, yeah, but if we do that, we break all of our third-party integrations, which we can fix, but it takes a long time. So ultimately, when you discuss security, you have to consider economics. Now, here's a great quote by Avi Doglan. Security at the expense of usability comes at the expense of security. And here's a little thing that lots of security people won't admit, but is absolutely true, and that is, if the cost of securing something is more than the thing you're securing, it probably isn't actually worth it. But of course, trying to gauge how much something is worth is a difficult thing. That's really the hard bit. So, compliance, green ticks. I'm not sure how many of you do compliance. We'd all love to say that we do, we're given compliance, we follow them, they make us more secure. But we all know there is a disconnect between compliance and actual security, and sometimes it does feel like a bit of a box-ticking exercise. And then you end up saying things like, yeah, I guess we do that in spirit, kind of. Here's a third one on the list. Yes, we audit all third-party code we use. Now, lots of customers will ask you this. They'll say, you audit all of the third-party code you use, right? And I think, yeah, last time we did a Ubuntu LTS release, I literally manually inspected all the lines of changes in the kernel scheduler patch. No, of course we don't. So when we make these claims to our clients, we're not following them literally, we're following them in spirit. We're saying that no, we're not going to inspect the microcode update in the CPU that the code's running on, because that's just ridiculous. But we are going to do due diligence with the libraries we import. We're going to be careful about not just bringing in random 3-star projects on GitHub that get abandoned. We're going to be using libraries from reputable companies, Apache, Google, or if not, then we're going to take ownership of the library. We're going to fix things ourselves, we're going to audit it ourselves. So AppSec. Now, we're at JVM Roundabout. We're not at Ops Roundabout or Compliance Roundabout. We'll have to ask Ben if there is actually an Ops Roundabout or Compliance Roundabout, but I don't think there is. So we're not going to be focusing on the Ops issues or the compliance issues. We're going to be focusing on the application security issues. Or if you want to be one of those really cool pen testers, you call it AppSec, because apparently that's application security is too long to say. So here's a real-life story. Here's Wired. They have a slightly withering headline here. And we're all going to get on our high horse and be like, yeah, those guys, so bad, right? But the truth is, we are all Equifax. How many of us, in any project that's lasted longer than a few years, have grabbed a random library from GitHub, or Maven Central, we've imported it, and it's kind of works, the clients like it, the customers like it, gets the job done, and then you look back at the code 3 years later and you think, well, we don't really know what the library does, we don't know how it works, we know it kind of works. It's actually very easy in practice to have dependencies that are vulnerable for months on end, because that's what happened with Equifax. Equifax were owned because they had a dependency called Apache Struts, and it was a few months out of date. And lots of developers got on a high horse over this when they heard about it. They kind of sent on Slack saying, aren't these guys so bad? But I think all of us can admit that we have all had dependencies that are more than a few months out of date, and not even projects we're running, just old code bases that have gone moribund in our kind of all of our repositories. So I'm not here to give Equifax a hard time. They made a script that any of us could have made, but they were very visible, and they were the ones who got caught out. But this isn't a security roundabout talk. This is a JVM roundabout talk. So of course, time to get to actual code. So rather than death by power plants, you're going to have death by code slides instead. Now, I'm not going to cover every single vulnerability under the sun, because I'll be here forever, and I'm sure you want to network at the end. So I'm just going to go through a few interesting ones in code that have caused vulnerabilities in the past, so you know not to make the same mistakes. By the way, shout out to Annetta, our designer, who did these nice kind of images. It's very cool. So vulnerable libraries. Not sure if this is a supply chain attack or the library we're using is actually that insecure accidentally. When you see some vulnerabilities in some libraries, it's really hard to tell the difference sometimes. You think, is this just, it's like the old rule of, is this malicious by kind of incompetence, or is it malicious by intent? A lot of the time, some mistakes are so bad you actually can't distinguish between them. Here's just one of many, for example. CVEs, for those of you who don't know, are kind of a really good way of categorizing vulnerabilities and their impacts and many other things. The kind of security industry has lots of these kind of standards you follow for kind of categorizing security holes and where they come from. And they seem a bit bureaucratic at times, but they do give you a good overview of a problem. So targeted supply chain attacks and accidentally insecure libraries do actually have similar solutions. And the first one there is really the important one. And this is something that I think kind of younger development practices are really bad at. In the olden days, Java developers are seen as a bit old-fashioned because we like to pull in Apache Commons, we like to pull in Google Juice, we like to pull in maybe Spring Framework and some other things, but we don't have like the many micro libraries approach of Node.js. And many people say, well, that's old-fashioned, we should adopt the Node.js approach. But actually, the great advantage of the Java approach of having a few monolithic libraries is that the cost of adding a library is much simpler because they're by a well-known company. It's not by some random GitHub project. So knowing the cost is really important. And Maven Central does have a far sort of stronger guarantees in terms of verifying who people are, slightly stronger than NPM. And there are fewer low-quality packages, but ultimately, we still can't trust every single person who uploads something onto Maven Central. So this is still a real problem. So are the authors reputable and well known? Because ultimately, the security of your code base is the lowest common denominator of all the people who contribute code to your code base, both via libraries and via your code. So if you have all your developers, they've got multi-factor authentication turned on, and they have maybe they're using UB security keys to authenticate before they can push code and all of this, that's great. But if you have one library done by a random guy who just doesn't have MFA from a GitHub project and he gets hacked, well, remote code execution on your servers. So it's worth keeping that in mind. So as it's not 1998 anymore, I'm not going to cover really old school vulnerabilities, like back in the day when people would have like hand-rolled frameworks that would have isadmin1 cookie. Yes, people used to actually do that. But sometimes the classics never go out of style, like SQL injections, JQL injections, whatever. So injections, of course, are a very simple thing. You guys were probably taught 10 years ago. You have to escape your parameters, right? But here's the thing. Nesting languages inside other languages can lead to injections even when you have escaping turned on. But before we get to that, let's just start with injection 101 for those of you who may be new to developing. So here's just the 101 thing. You have a JQL query. You run it in Hibernate or your JPA provider of choice. And then, of course, if we look at the where name like match thing, here the developer has said, oh, well, I know how to escape parameters, but I don't know how that works when you use the % signs to say like something. So I'll just put it in directly. And then, of course, that can be, then they can just say like close % sign, close speech marks, comments, and then just do whatever the hell they want. And then, of course, here's one that actually affected Ruby on Rails. So it's kind of outside of our ecosystem, but sometimes you think there's a very small amount of input, so you don't bother escaping it because you think, well, they'll leave the pass ascending or descending. And then, of course, they can actually pass whatever they want because you don't escape the URL parameter. Now, all of this stuff is all well and good, but let's be honest here. This is injection 101. You guys already know this stuff. So now let's do something a little bit trickier. Let's do free marker server-side templates. And for those of you who are on Scala or Mustache, know that the Clojure and Scala ecosystems have very similar problems with their server-side templating of choice as well. So for those of you who don't know free marker, back in the day, people used to use it a lot to design UIs. Now, people tend to only use it for things like generating email templates and other things. We tend to use more Ajax and React for doing front ends now. But you still see it loads in the wild, and you're probably going to maintain code that does use it for UIs. So the general gist is that you set a value in the backend code, and then your designer theoretically can write a large HTML file, and then they can just use $brace or whatever to take values from the backend and put it in. Right? You've always seen this one before. So you get that, and what's happened there is it's escaped the kind of angle brackets, and so the injection has failed because it just gets written out manually. So I'm going to end the presentation now because we're all done. You just escape, right? Well, not so fast. Because here's the problem. You can escape HTML, but that doesn't mean you are escaping the sub-languages that you can embed inside HTML. So here's one for you. Imagine you have a main HTML that is like a master server-side template in an old backend you have. And then you're mostly templating things. You're kind of enumerating the user accounts. You're enumerating the top-level things to have on your index page. Then at the top, you decide you want to add Google Analytics. But because you support multiple environments, you have a different analytics token per VPC or per customer you have. So you decide, well, we have put the analytics setup code in the top script, so let's just parameterize it with a value. And of course, it's fine, right? Because it's escaped. I mean, it's still in free marker. It's still in escaping mode. But here's the problem. If you run this through free marker, that looks a bit wrong, doesn't it? Because, yeah, we're escaping, but we're escaping HTML. Now, this is HTML, right? But the problem is that we're using a sub-language inside HTML. So what we do is we use this very politely named tool here to basically generate an obfuscated payload that only uses a subset of characters. And this is great, by the way. If you do pen testing, this tool is really good. Just search for it. Make sure you put the JS before it, though, otherwise you'll get fairly strange results. And then when you do that, you then can do that. And then what that means is, even though that is escaped, even though you had escaping in your templating language, you injected a sub-language inside the outer language, and so you just bypassed all of the escaping systems. So the moral of the story is that firstly, don't embed languages. It's 2019. If you can avoid embedding languages and strings inside other languages, don't do it, because embedding languages will always lead to problems like this. If you have to embed languages inside of another language, then you have to make sure you escape every single layer. So for example, if you have inline JavaScript inside HTML inside FreeMarker, you can't just do FreeMarker escaping. You have to do FreeMarker escaping and then escape it to move it from the HTML layer into the JavaScript layer. So everyone thinks they can do escaping, but unfortunately, nested languages can even make this basic thing go wrong. So let's talk about something slightly different, which is serialization bugs. So the typical Java scenario, cool little bug image there, thanks Netta. You have a JSON payload, and you want to load it into your system. But of course, as a really good object-oriented developer who read Gang of Four, you've read Bob Martin, you've read all the literature, you, for some reason, decide you want to do an inheritance hierarchy, which is questionable, but people seem to love doing that 5 years ago. So you end up with like an account, and then you say, but we want a current account for our bank, so then we're going to do a subtype, which obviously is totally contrived. It's probably not actually how it works. But here's the thing. If you're serializing things from JSON into POJOs, if you pass a subtype and you want to store it in a supertype, you want to serialize it into the supertype, but you don't want to lose the information in your subtypes. Because then if you cast it into the subtype later on, you don't want to lose all of those fields. So what Jackson did, Jackson is the de facto JSON parsing and marshalling library, is they added something called enable default typing. And what this does is it allows JSON payloads to declare which class they want to instantiate. So you can say, they basically get to decide, and then the client can say, I'm loading this into an account class, we're storing it as an account, but then the payload itself can say, but I want this to be a current account, I want it to be a standard account, and then they can decide what to do. Now this doesn't give them the ability to run whatever code they want. It only gives them the ability to implicitly trigger getters and setters and type construction. But as we know, there's no instance ever of Java code in the world ever using a constructor with side effects, right? So this is where serialization gadgets come in. They are known combinations of type constructors, setters, and getters, which when combined together, give dangerous side effects. Now, I'll be honest with you, I'm not intelligent enough to know how this works. I just stole this from somewhere else. But this was from a commit from FastXML, Jackson. And they put this example into their code to show a particular vulnerability that calls the CVE. So the problem here is that the object here is just a random Java payload, but it's using a special syntax understood by Jackson, where it says, this is the thing where this is the POJO we want, but this is the actual concrete object we want to create. And as you can see, the payload can basically pick any class on the class path. So alarm bells should be ringing in everyone's heads right now. Without going into too much details, the problem here is that you can indirectly set this bytecodes property by just using a setter. So again, not a side effect, just by invoking a setter, by just setting a POJO value, you trigger the bytecodes. But here's the problem. They broke the cardinal rule in Java, which is you don't have side effects in getters, because get output properties gets the output, but if the bytecode hasn't been run yet, it runs the bytecode for you. So that means by serializing a POJO, the person could just specify a whole bunch of bytecode they want, and then just invoke the getter, and then they basically have remote code execution. And I would love to say that Jackson solved this by just saying, this is clearly a terrible feature that we should never have added. Let's get rid of it in the next major version. But they didn't. What they did is they maintained a magic blacklist of known dodgy things that they hope won't trigger this case, which is a little bit worrying, honestly. So yes, this feature still exists in Jackson even today. In order to not hit this, you have to not use the default typing feature. And yes, theoretically, this list will get rid of common known bad things, but it's blacklisting never works in security. So this is like security through layers, really, at best. It's not that good. So if you want to see more information about this, you can follow this link. The slides will be made available. DOS attacks. Now, for a long time, we've been quite smug in the JVM ecosystem because we've had a thread per request for all of our web services. So we kind of looked over the Node.js guys having all of these regular expression DOS vulnerabilities, and we're like, well, we don't care. It's not affecting us. But unfortunately, Node.js's problems are now our problems. So for those of you who don't know, the Node.js ecosystem problem was that if you have a regular expression that's written in a certain way, and the user provides certain inputs, they can create inputs that create exponentially increased computations to work out whether it's a valid or invalid match. And if you do that, it means you can lock up a whole thread for like half a minute just by having a 40-character string. So that means a single person making a request can just put something in the HTTP payload, and then the whole thread's dead on the server. Now, in Spring MVC world, that's quite bad, right? But it's not the end of the world because you just block their request. But enter non-blocking Java web frameworks like Webflux. Now, the thing about non-blocking tech is it's taking a small amount of threads, and it's trying to maximize the utilization across the logical processes you have in your system. So it isn't giving a thread per request anymore. It's giving a small thread pool for all requests instead. So suddenly, the cost of blocking is now a lot higher than it used to be. And this means that Node.js's problems are now our problems. The whole point of a DOS attack in security is that if an adversary can spend a tiny amount of their resources to spend a whole lot of your resources, that's going to end badly. So for example, as I said earlier, if you send a regular expression with massive amounts of complexity, that's like a 200-byte Unicode string in a HTTP request. I can do that from my iPhone, right? It's nothing. But if you run that against a server that's handling tens of thousands of clients, if you lock up a thread for like half a minute, and you've only got a thread pool of 6 threads, handling loads of people, that's a serious problem. So if we just do the quick maths here, let's just say hypothetically we have a server that has, say we have 20 threads allocated to handling web requests, which is not an unreasonable amount. In fact, if anything, that's higher than most systems we use. That means that if someone manages to send a request that takes 5 seconds to run, that means one guy with like a £120 netbook in Starbucks can basically take out a whole server. Now, yes, your DOS protection may kick in. Your DOS protection may say, oh, we're seeing suspicious requests from this laptop. It's the same IP over and over again. But the truth is, if one request can lock up a server for that long, 30 seconds, which actually my example does, then you can probably lock up a server without even triggering the DOS protection, without triggering a web application firewall as well. So here's an example of this in Spring Webflux. Now again, this is overly simplified. In a well-organized code base, you're not going to be doing ad hoc regular expression checks directly in the handler layer or controller layer if you're from MVC land. And yes, this is a slightly convoluted regular expression because actually they kind of fix this in Java 11. So you have to do like power of 3 complexity to make it really bad. But if you pass in like a large thing to that regular expression, the code's just going to be locked on this line for basically a long time. Now, the examples I've shown you today are just 3 examples. And there are many, many more examples. I picked 3 that looked good to me. But if you go to the OWASP Top 10 project, which is the darling of security professionals, you can see a whole wide range, a whole list of potential problems like this that allow people to attack you in the CIA triad. That is, they can attack your confidentiality, your integrity, or your availability. So remote code execution, for example, can hit most of those things if done properly, whereas the DOS problem I showed you will mostly attack your availability. So most vulnerabilities will target some permutation of C or I or A. So to conclude, it's very easy to throw code over the wall and just say, well, my code's working, and now it's up to the ops team to secure the servers and make sure the hackers don't break in. The truth is, as Java developers, as Clojure developers, as Scala developers, the code you write directly impacts the security of your system. And you can have the best firewalls, the best WAFs, the best whatever you want. But if you screw up a piece of code, all of that can be just rendered moot. And by the way, we are hiring. And yeah, I know. So I haven't really recited this part, which is why my CTO is giving me that look now. Thank you.